So can you see my screen?
Yes, I can.
Okay. So yeah, this was the question. 3x squared plus 2xy plus y squared equals 6, right? This was the question I gave you in the test and you were not able to do it. That's completely fine. We'll do it now. Yeah, I can use the red pen. Okay. So you were asked to differentiate. Okay. So by looking at the question, we can determine something about the nature. X and Y. So we have a mixture, right? Can you hear me? Okay.
So you're supposed to use the product rule.
Yeah, we are supposed to use the product rule. Agreed. Just give me a second. I'll connect. I'll reconnect. Okay, I'm here, but I have to connect to my
Okay.
internet. Okay, we are back. Can you hear me?
Yes.
Okay, perfect. So this was the question, 3x squared plus 2xy plus y squared equals 6. And we were asked to differentiate. So x and y are combined, right? You are very right, we'll be using the product rule, but before product rule, we need to determine something else. That since x and y are mixed, so this is implicit differentiation, right? We need to determine
Yes.
that thing first. Okay, so we know that we'll be solving this to implicit differentiation. So let's start off by step one. Step one is to differentiate both sides
With respect to X.
excellent. So we will differentiate with respect to x. 3x squared plus 2xy plus y squared equals 0 because the derivative of 6 with respect to x is 0, right? Now we will differentiate each of these. Derivative of 3x squared would be
6X.
6x plus, now we need to know the derivative of 2xy, okay? We will do this in rough work, but make sure that you give your rough work as well, okay? Because my niece has this habit of bringing rough work back. So that's why she gets 0 marks. So yeah, you need to differentiate this. Now we will be using the product rule, okay? So let's say we take 2x as the first function. So 2x would come as it is derivative of the second function. So what is the derivative of the second function? Simply dy by dx, right? Obviously, because it's y, we differentiate it with respect to x. And now listen to me. You directly have dy by dx. So now you don't have to apply the chain rule, okay? This is good enough to go like this. You cannot break it down further into something. This itself is in the simplified form. So this would be dy by dx plus the second function would come as it is, and derivative of the first one would be 2. So I can write it down here. I have 2x dy by dx plus 2y. Now I have y square. I will differentiate y square with respect to dx. Now I can see that this isn't y. This is something I cannot differentiate with respect to x, so I need to do something, okay? When we know
Chain
that, we
rule.
have to excellent. So chain rule, the trick to chain rule was, this is the numerator. I'll write this numerator here, and this is the denominator. I'll write this denominator here. Now I need something over here and over here such that I can differentiate this y square. So the only variable I can differentiate y square with would be dy, would be y, right? So I will be differentiating it with respect to y, right?
Yes.
And we know that these two things are same. So you'll have dy here, okay? This is how you use the chain rule, okay? This is the
Yeah.
chain rule, okay? Okay. So we can write it down here, plus dy square by dy into dy by dx equals 0. Next, we will simplify things. 6x plus 2x dy dx. Let's just write down the dy dx terms together. Again, we have dy dx. And what is the derivative of y square with respect to y?
2y.
Very good. Plus, we already had this 2y equals 0. 6x. So what is the next step? We need to separate the dy dx term. So I'll take it common. I'll be left with this. This is 0. Now I'll take this to the other side. Why? Because I need dy by dx. Is it clear?
Yes.
So this is minus 6x plus 2y divided by 2x plus 2y. So this is how you were supposed to do this question. Is it clear?
Yes.
100%?
Yes.
Very good. So we are going to do another question. Clear all? Okay, again, I'll use different colors to make it look better. So the question again is find dy by dx for the curve x cube plus y cube equals 4xy full stop. Okay. So let's do it. Solution. Again, one thing is clear. We have to find dy by dx. Okay. But dy by dx of what? Of an equation where you have y equals f of x or where f and x are mixed. Where x and y are mixed. X and y are mixed here?
Yes.
So this implies that we'll be using implicit differentiation. Yeah. Here the question, here the equation, here the curve was not of this type. It was not of this type. If we had an equation like this, we would have simply differentiated both sides and we would have dy by dx on the left hand side directly. But things are not like that. We have a different scenario. Our equation has x and y both mixed, that which implies we'll be using implicit differentiation. Okay. So let's differentiate both sides with respect to x. D by dx of x cube plus y cube equals d by dx of 4xy, right? Okay. Now we need to differentiate both sides. So the derivative of x cube with respect to x is
3x square.
very good. And what about y cube? Is it 3y square? Is the derivative of y cube with respect to x 3y square?
No.
Very good. Excellent. So we know that it is x over here and we have y in the numerator, so we cannot differentiate it this way. We will use chain rule. Okay. So we have dy cube by dx. So now we have to use the chain rule. This is in the numerator. Do you know how to apply chain rule clearly?
Yes.
Very good. So we have dy multiplied by dy. Derivative of y cube with respect to y is, now this is 3y square.
3y square.
Excellent. Into dy by dx. Okay. Right, so we'll do it in the next turn now. Okay, this is equals to, now we have a product here. So we'll be using the product rule. We have d dx of 4xy. So let's say that 4x is the first function. 4x would come as it is, and derivative of the second one would be dy by dx. Plus second would come as it is, derivative of the first one, that is 4x, would be 4, right? Do you understand this?
Yes, I do.
Okay. 3x squared plus, we are going to write down this thing. This is 3y squared dy by dx. Now I'll take this to this side because I want to separate dy by dx, okay? Minus 4x dy by dx equals 4y, and I'll be taking 3x squared to that side because I need to isolate dy by dx. Why? Because this is what I was asked to find. So I can take dy by dx common. 3y squared minus 4x, 4y minus 3x squared. So I'll be left with dy by dx equals 4y minus 3x squared divided by 3y squared minus 4x is the answer. Is it clear?
Yes.
Okay. So can you see the spotlight?
Yes, I can.
Okay. So basically, just remember, never ever get confused. I asked you to solve a question which was supposed to be done through implicit differentiation. So what was the clue? XY was clue. Okay. I don't remember what we had in the previous question, but let's say if I ask you to solve this one, XY is your clue, and XY will tell you that you need to do it through implicit differentiation. And when we are saying implicit differentiation, two things should be clear: product rule and chain rule. Two things would be used. Okay. Now we had y cube here, and we cannot differentiate y cube with respect to x. Although we can write it down for doing it stepwise. So this is what we did. We have written it in the first step, and then I have differentiated y cube with respect to x by using the chain rule. I know that I can differentiate y cube with respect to y, and I know how to apply chain rule. So your goal in such questions is to get dy by dx. To get dy by dx, and then you have to make it the subject of the equation, just so you are left with this dy by dx, and this is what you had to find. Okay, is it clear?
Yes.
So you want me to do another question, or it's fine?
No, it's fine.
No, tell me honestly. I can do. I have another question as well.
No, it's fine. It's fine.
Okay, perfect. Okay, now let's talk about our new chapter, new topic, integration. Integration. And the topic is trapezium rule. Okay, so let me take out my notes. Okay, yeah. So let's say we have a curve. And this curve goes on like this. This is A and this is B. So okay, this is Y, This is x and y equals fx. This, you know what this is, what this equation means, the basic idea behind it. That y equals fx means in English, y is a function of x. In other words, y is in terms of x. Okay, so never ever get confused by such equations, right? Is it clear now?
Yes.
Okay, so you have been given with these two things, and you have to find the area under this curve, find an approximation, sorry, of area under the curve. Okay, so this is what trapezium rule would help you with. Okay, trapezium rule would help you in finding the approximation of area under the curve. And okay, and you have been told to do it in n intervals, right? So we have a and we have b. Let's make it a number instead of writing n intervals. Let's say you've been asked to do it in 4 intervals. Okay, so I will have 4 intervals: 1, 2, 1, 2, 3, 4. And now I'll make my trapeziums. Okay, this is how you make trapeziums. These lines are supposed to be straight, and you will calculate the area of these trapeziums: 1, 2, 3, 4. You will sum that up, and then you will get an approximation of area under the curve, right?
Yes.
Okay, so area of trapezium 1 is 1 by 2 base. Okay, base. This is the base. This base is h, and in general area of trapezium is 1 by 2 h sum of parallel sides. This is the formula of trapezium in general, and this is what we have. So I will write down 1 by 2. Base is, we don't know the base. We know that h can be calculated by b minus a divided by 4. This h or the base would be same for every trapezium whenever you are applying the trapezium rule. So when I'm saying that it would be same, it means that the lengths between a and b would be divided equally into 4 intervals, right? So the length
Yeah.
between b and a is b minus a. When I'm saying it would be divided equally, I'll divide it by 4. And every trapezium 1 would have this. Let's say this is y. Okay, let's say this length is y. This would have y length, this would have y length, this would have y length, and this would have y length. Okay, so all of these would have same length. So I will write down y. And when we are saying sum of parallel sides, so let's say this point is y naught, this is y1, then this is y2, this is y3, and then finally we have y4. So 1 by 2 base y, sum of parallel sides, y naught plus, what is the other parallel side of this trapezium 1?
Y1.
Very good. Excellent. Okay. Okay. So then we have area of trapezium 2. I want you to help me. 1 by 2
1 by
y.
2 y
Yes.
and y2 minus y1.
Y2 minus y1 we sum.
Y, yeah,
We
sorry. Y2 plus y1.
okay. So we can write down y1 plus y2. Okay, because
Yeah,
we
y1 plus y2.
very good. Then if we talk about the area of trapezium 3, it would be 1 by 2 y, y2 plus y3, and then area of trapezium 4 would be 1 by 2 y, y3 plus y4. Okay, so you need to see one thing, that if I sum, because I know that the area under this curve, the approximation of this area would be sum of all these. Okay, so I'll write down sum of all areas is this 1 by 2y, 1 by 2y, 1 by 2y, 1 by 2y is common. So I'll write down 1 by 2. Instead of y, I use h, because h is the general term and it's good that you learn the formula with h. Okay, so I'll write down h. H and y are the same things, right? You can see this.
Okay.
Okay, so now I will write down these things. So I have y naught. I'll write down y naught plus y1 plus y1 plus y2 plus y2 plus y3 plus y3 plus y4. This is what I can write.
Yes.
H. Now y0 and y4 are coming once only, and the rest of the terms are coming 2 times. So I can write it down like this. Is it clear?
Yes.
Okay. So this is the general formula for trapezium rule. Approximation or approximate area under curve. Now, okay, sorry. I need to write neatly. Curve. Okay. Let me make a box. This is the only thing you need to remember from example. Okay, so just write down this right now using a red marker if you have on an A4 paper, and you can list down all these formulas and paste it on your cupboard with the derivatives, just so you remember things easily. Okay, this would help you in learning quickly, right?
Yes.
Okay, so yes, just give me a second. Yeah, okay. So this was the curve we had to approximate, and we did that by basically breaking down this area into trapeziums. 1, 2, 3, 4. This number, this number of intervals would be given. This is not something that you will choose on your own. Yes, you can if you are not given and you have been asked to do it through trapezium rule, but most of the times you'll be given with this number. Okay, now with the help of this number, you will calculate the base, the h, and this h would come here in the formula because this is same for every trapezium. So with the number of intervals and with these two limits, you will calculate the base or h and you will get it here. Now these y0, y4, y1, y2, y3 would be calculated using this equation, using y equals f of x. You will be knowing that y at y0, your x is a. So we'll simply substitute a in place of x. A would be a number obviously, and you will get a number in y, and that y would come here. Okay, we will practice this. We will practice it. We will do some questions, so you will get a better idea. But yeah, are you able to understand it? That from where you will get these y's?
Yes.
Okay, very good. Now another thing. This approximation can either be an underestimate or it can be an overestimate, right? Because at the moment we can see that it is an underestimate. Our area is less than the actual area that the curve would be covered under the curve, but our approximation is giving us an underestimate. So the question could be that you have to determine that. How you will determine that? Okay, you will determine that by, they will only ask you this thing whenever you are able to integrate the question otherwise as well. Okay, and you would be given good enough marks. So if you have good enough marks, you have to spend good enough time. So you will be calculating the integral of this function directly. Let's say that, okay, I'll do it here. You have y equals f of x. So the actual area is basically the integration from a to b of f of x dx. You need to calculate this and you need to calculate this. And if this is greater than this, then if the approximated area is greater than the actual area, then it is going to be an overestimate. Overestimate would be when the approximation is greater than actual area. And it would be an underestimate if your approximation is less than your actual area. Do you understand it now?
Yes.
Perfect. Very good. Okay. So let's move on to a proper example. Example number 1. The topic is Trapezium Rule. Okay, so this is first example. So this is again a curve like this one, and it's coming down like this. Okay, this is 0, this is 0 0.2, 0 0.4, 0 0.6, 0 0.8, and this is 1. And you have A, B, this is B, C, D, and E. Okay. So you need to find the area between 0 0.4 and 1.2. This is 0.2. And use 4 intervals to approximate the area under the curve, right? Okay, this is what you have. Now they are saying 4 intervals and the limit is 0.4 and the final one is 1.2. So let's just make the 4 intervals first. This is the first interval. This is first interval. This is second interval. This is third interval and this is the fourth interval. Now one thing I want you to see or notice, when you have 4 intervals, you will have 5 sides, okay? Side 1, this is the first side, second, third, fourth, and fifth. Okay, right. So we don't have to get into any of the concepts.
What
We
about
yeah,
what about the interval from between I mean from 0 to a?
0 to is this one, right? 0 to
Yeah.
0.4. Okay. So I have not mentioned this. I have not written this in the question, but you would be given a particular area, like some area would be shaded. I'll shade this area, and they would be only interested, or they would only ask you to find this particular area. Okay. And in that case, if you have to find the actual area as well, if they ask you to tell if this is an underestimation or overestimation, in that case, you will integrate it from 0.4 to 1.2. Okay?
Yes.
Do you understand this now?
Yes.
This is y and this is x. So it could be that you have a big curve, but they are only interested in finding a particular area under particular portion. Okay, so in our case this is the portion. Okay, so now we don't care about what our trapeziums are and everything. Maybe I can draw the trapeziums just for the concept, but in exam you would not be asked to draw the trapeziums. We only know that the area would be 1 by 2 h y naught plus, okay, this is y naught, y1, y2, y3, y4, the final one plus 2 times y1, y2, y3. Now listen, first you need to write down the formula according to our case. Our case had 4 intervals, right? So when we have 4 intervals, when we have 4 intervals, since it is starting from y naught, although we have 5 sides, but it is starting from y naught, so the last side would be y4. Okay, be clear with this.
Okay.
4 intervals imply 5 sides, and the final would be y4. Why? Because it is starting from y naught. Okay, starting one is y naught and ending one is y4. So obviously y naught, y1, y2, y3, y4 are 5 sides. So if you have 4 intervals, you will have y4. If you have 5 intervals, you will have y5. Okay, so you have to write down a formula of the area as per your question. Now we need to know what our y naughts are. Okay, so let's talk about the y naught. Now in this case particularly, you are given with a scaled graph. Although my graph doesn't look like it is scaled, but either they would give you a function, let's say they will give you y equals x square, and you will know that your x naught, what is our x naught?
0.
X naught is the starting x.
Oh, so that will be 0 or
No. The starting x, basically the one whose area we are finding. This one. 0.4.
0.4.
Yeah, so y would be 0.4 square. Okay. Anyways,
Okay.
we will discuss this type of example after this one, but here We need to find the y's and x's from the graph. Okay. So first step 1. We have our formula. We need to know the h. H would be, what is the final limit?
1.2.
And what is the starting limit? Now look, your starting limit,
0.1.
your starting limit is,
0.4.
yeah, your starting limit is not 0, your starting limit is not 0.2. Your starting limit is basically the starting point of your trapezium, the starting point of the area that the examiner wants you to find. Okay, so here he wants you to find the area between these 2 points. So this is our A and this is our B, because H basically is B minus A divided by N, where N is the number of intervals, B is the final X limit, and A is the initial X limit. So this is what we know. So what are the number of intervals?
4.
Very good. So H would be 0.2. Now if 8 is 0.2, I know that this thing would be 0.2, 0.2, 0.2, 0.2. But we are interested in finding out these. So 0.4 plus 0.2 is 0.6. Do you understand how is it 0.6?
Yes.
This would be,
0.8.
and this would be
1.
very good. Now we have our values. Okay. So step 2 is to make a table. Step 2 is to make a table where you will, I need to change the color. It's not very obvious. Okay. So you will have x's here, you will have y here. Okay. Now your x naught or first x is, but what is our x naught?
1.2.
This is our x naught.
Oh, 0.4.
And this is our x4. Okay, so x naught is 0.4. Very good. Then x1 would be
0.6.
0.6. Then x2 is
0.8.
then
1.
very good. Okay,
1.2.
so this is something we had from the graph, or from the graph, but this is a technical part. Okay, we need to find the y. Now for finding y in our example, we need to use this graph. We will see this is y naught, this length is y naught, this length is y1, this length is y2, then this one is y3, and this is y4. So we will simply calculate the lengths using by doing this way. So I already have calculated, because obviously you cannot tell me the exact values through this. If the examiner wants you to do it through graph, he would give you a scaled graph, right? So the
Yes.
values are basically 0.9231. Then we have 0.8353. Then we have 0.7261. Then we have 0.6065. And finally we have 0.486. Okay. So these are the values. Now this is y naught, this is y1, y2, y3, and y4. Now we have h, we have y's. We can simply calculate the area by plugging in all these values. Do you understand?
Yes.
So y naught is 0.9231 plus y4 is 0.486 plus 2 times. Never ever forget this 2. y2 because y1 is being shared with two trapeziums. Trapezium 1 has y1 as one side and trapezium 2 has y1 as one side. Y2, again, it's over here after this 2. Why? Because it is being shared by trapezium 2 and trapezium 3. Okay. So you have plus 2 into y1 is 0.8353. Y3 is 0.7261. Y1, Y2 and Y3 is 0.68, 0.6865. Okay. And if I calculate it, the area would be 0.5746. Okay. So do you understand it now?
Yes, I do.
This approximation told us that we need to use the trapezium rule. Either they would tell you to use trapezium rule or they would ask you to approximate. Okay. And you were given with 4 intervals. So step 1 is to write down the formula as per your question, because it could be that you had 5 intervals, so formula would be different. Okay, then the basic idea would be same, but these y1, y2, y3s would be different. So you have to write down your area. Then you need to find out the h and these y's. For h, you will use the ending limit of the area, the initial limit of x for the area, and you will divide it by number of intervals. So this is h, and this base is of every trapezium. So this would come here. Next, you need to find out your y's. So for finding out y's, you need to first find out your x. In this case, particularly in this case, you could have calculated y's or found your y's without finding x's, because you had graph and you were asked to do it through graph. But in the next example, you will see when we'll be given with a function, you will substitute these x's in the function just to get these respective y's, and then you will plug in these y's in this formula to get the area, right?
Yes.
Is it clear?
Yes.
Okay. So I will take out the question now. Okay. Right. So we have another example. Another example. And first, let's draw the curve. So we have a curve of this sort. This is the starting limit and this is the ending limit. This is 0.5 and this is 3.5 and this is y and this is x. Okay. And the question is, the diagram shows the curve y equals x minus 2 ln x. Okay. So the question says to use the trapezium rule with 2 intervals. Okay. I will not write down the whole question. Full stop. Use 2 intervals to estimate the shaded area. I'll shade the area. So this is, these are the limits, and this is our shaded area. Okay. Okay, perfect. Now, okay, so we don't have to, think about that how we would make the trapeziums in this case. All we need to do is we are given with this function, so things are very, very easy in this example. Okay, let's move on to the solution. Okay, so step one. Again, we'll start off with step one. So step one is to find h. We will write down the area formula, but let's just talk about h. H is, what is the final x limit?
3.5.
Excellent. And the initial one?
0.5.
Very good. And what is n?
2.
Very well done. So h would be 1.5. Okay. Now we have our h. We know we'll have two intervals. So this would be trapezium 1, this would be trapezium 2, and this is going to be 2 because this is 1.5 and this is 1.5. Okay, perfect. Let's write down the formula of area. Approximate area would be equal to 1 by 2 h. Okay, now this is y naught, this is y1, and this is y2. Now Ranjani, notice this, that we have two intervals and the final side is y2, just like the previous one, and the first side is always y naught. So we know that we will write down the first side and the last side without the 2 because it would be once only, and we will write down the rest of the remaining sides that are coming in between the final and the last one 2 times, that is y1. Is it clear?
Yes.
Okay, so we have our h but we don't have our y's. Now to find the y's we need to make a table, and yeah, okay. So first we need x's and then we will find y's. Now listen, in the previous example you could have used y's directly because you had to do it through the graph. But in this case you need to use this y equals x minus 2 ln x. So you need x's. Okay, why? I'll tell you why. So what is x naught?
0.5.
Very good. 0.5. What is x1?
2.
And x2?
3.5.
Very good. Now we need to find the corresponding y's. Okay, now we need to find the y at 0.5. The y at 0.5 would be this. So what would be the y? It would be 0.5 minus 2 ln 0.5. How? I have used this
So
formula
that's the
here.
equation.
Excellent. Okay, so we will do it through calculator and we will get
1.89.
Yeah, very good. So yeah, this is the what I'm getting. Right, so this is 1.89. Let's write down the till 2 decimal places. Then we have y at 2. This is 2 minus 2 ln 2. So this would be 0.6137. That is 0.61 And then we have 3.5 as x. So this would be 3.5 minus 3.5 minus 2, sorry, ln 3.5, and we will get 0.9945. So this is 0.99. Now to find the area, we are going to plug in all the values. So h is, what is h?
That is
H is the base, okay? H is the base. And we have
so
calculated H.
1.5.
Very good. So Y naught is, what is Y naught?
Y naught is 1.89.
Very good. What is Y2?
0.61.
Yes. No. Wait.
Y2 is
Sorry. Yeah. No, this is not Y2. Yeah, okay. What is Y2? This is Y naught.
0.6.
This is Y1. And this is Y2. Okay, I told you. The counting
Yeah,
is starting from the 0. So Y2
0,
is
0.99.
very good. Plus 2 times y1, that is 0.61. So the answer is 3.08. Okay, this is the answer.
Yes.
Now in this case, if we if we draw the trapeziums on this curve, they would look like, not like this. They would look like this, and this would be this one. Okay, so our area is basically this area. So is it an underestimate?
So like integrated to check, right?
No, but is it, no, but yeah, excellent. But as per the drawing, what are you understanding? Is it an underestimate or overestimate?
Underestimate.
It's an underestimate?
Overestimate. Overestimate.
Very good. Excellent. So it's an overestimate, but obviously you would not be wasting your time in drawing and checking, because you would never ever be able to check it correctly through your drawings without
Yeah.
the scale graph. You will use this. You will use this equation. You will calculate the area by integrating x minus 2 ln x from 0.5 to 3.5, and you will then check your answer and you will compare it with this answer. If this answer is greater than the actual answer, it is an overestimate. If your approximation is less than this answer, it would be an underestimate. Is it clear?
Yes.
100%?
Yes.
Okay, so you will be doing the next question. Obviously, I'll help you, but just so you know, I need to see if this concept is clear or not, because trapezium rule is easy, and it's very likely to get a question from this topic. It's very likely because it looks easy, but students usually mess up with the y's, mess up with the number of sides and intervals, and then they can definitely give you a 5-mark question in exam. So this is an important topic. So the question says, the question is, the diagram shows the curve y equals to under root 4x minus x square use trapezium rule with 4 intervals to estimate the value of now why have they written this? We usually estimate the area under the curve, but here the question has a different statement. They're asking us to estimate this value. So how would you answer that?
I mean the value of
Sorry?
you're asking us to estimate the value of, so you just use the trapezium rule and
No, my question is that usually the question says to estimate the value under the curve. But here they are saying value of this integral. So basically the value of this integral is what the area under the curve is. Isn't it so?
yeah, yes.
So never ever get confused by statements, okay? Right.
Okay.
So I will plot the graph. And I repeat, this is a very important topic. It is easy, but it is important. So you need to practice a lot because even I get confused at times. It is basically a proper curve, although it doesn't looks like one. Doesn't look like one. So I'll write down 0. I'll write down 4. This is y, and this is x. And this question is for you. Obviously, I'll help you, but I want you to estimate the value of this integral, right? And I have shaded this part for you. And these are your intervals, and this is your curve, and you can try it now. Okay? Can you do it? Can you try doing it?
Yes.
Very good. Start doing it then. Take your time. Okay?
Yeah.
I can give you 5 minutes.
The area between 0 to 4, right? The values of x.
Yes, because
0 to
you
4.
you have been asked to integrate this, and this is basically, sorry, let me write down the limits as well, from 0 to 4, right? But I already shaded this whole thing. So yeah, okay.
Is it 21.9?
The area, the final answer?
Yeah,
It is 10.93.
10.93.
Yeah. Okay, it is okay. It's okay. I'll solve it and let's see how to do it. Okay. Right. You can always cross check your solution step by step. Okay, maybe you just made mistake at a step and then you end up getting wrong answers, obviously. Right.
Oh, I know where I went wrong. It's square root. It's
Yeah.
2 root 4x minus. Just 1 second. I'll just.
Okay, okay, take your time.
Can you solve it?
Say it again.
Can you please solve it? I
Yeah,
think.
sure, obviously. Okay. So we have been asked to estimate the value of this integral. Okay, the statement here is a bit different, but the statement more or less means the same thing. Area under this curve has the equation 2 under root 4x minus x square. So the area under this curve with limits 4 and 0 is basically the value of this integral between 0 and 4. Okay, so this is the same thing. And we need to estimate. Estimate means to use the trapezium rule and to find the approximate answer, right? So we don't care about what the sides and everything would be. We will write down the formula of area first. Area would be 1 by 2h. Okay, we do care about one thing, that the first side would be y naught, y1, y2, y3, and y4. Now in this case, our y naught is basically 0. This is basically a triangle, but it is completely fine. We will do it through the trapezium rule and we will find the answer. Okay. This again is coming till here, but yeah, okay. So this is h, and now we need to write down the first one and last one once only. So y naught plus, we have 4 intervals. This 4 is telling us that our final y would be y4 plus 2 into the inner sides. Okay, so the inner sides are y1, y2, y3. You don't even need to look at the diagram. You have 4 intervals. You should know that 4 intervals imply the final length would be y4. The starting one is always going to be y0. Even if it is 0, we will still write down y0. And the ones coming in between would be the remaining ones, right? After y0, we have y1, y2, y3, and we have 5. This is the formula. We need to know the y's, okay, and we need to know the h. H is the base. H is basically the final x limit, that is 4, minus the initial x limit, that is 0, divided by number of intervals, that is 4. This is 1. So each base of each trapezium is 1. And we need to determine the y's now. So we have 4, xy would come here, then we have first set, we have second set, we have third set, and then we'll have the fourth set. Okay. X and y. So what is x naught?
0.
Very good. X1, X2,
1, 2,
excellent.
3, and
Yeah, sorry, okay, I've
yeah,
missed
3. No need for
this
4.
3 and this is 4. Wait, yeah, okay, yes, definitely. This is going to be like that. I've missed y3. This is x3 and this is x4. Now what
Is the
is
answer 10.92?
10 point?
92?
Yeah, that is the answer. Very good.
I didn't multiply this entire thing by 1 by 2.
Yeah, okay. That is okay. This is why I said that just write down this formula on a
The formula,
white
yeah.
A4 and just paste it. You will learn these formulas easily, okay? So we will write down the values. This would be 0. Why it is 0? Because we need to insert a 0 in this. And this is 2 under root 3. This would be 4. You need to find these, okay, in detail. I'm just writing down because you're already done with the solution. And this is 0. And when you insert these y's, this is y0, y1, y2, y3, y4, and this h. When you will insert it in this formula, you will get 10.92. Okay, so I would like to mention a few things that are very important. You had 4 intervals. 4 intervals mean you will have y4 and x4 as the final ones. Okay, you will never ever have x5 or y5 because you will begin with x0 and y0. Be clear with these numberings. So you have 4 intervals, you will write down the formula directly. It is starting from y0, so you know that the first side is y0, that is coming once only. The second side is y4, that is coming once only. Why y4? Because you have 4 intervals. Okay, this number and this number is same, just learn it. Plus 2 times the remaining sides y1, y2, y3. Next, okay, you have written the formula. Now, obviously, you need the values to plug in. You need h, you need y's. You will calculate the h by doing this. B minus a divided by n. B is the final x limit, that is 4. A is the initial x limit, that is 0 divided by 4 number of intervals. You will have 1. Now you have x's, you have y's, and simply you need to plug in these into the area formula. Okay, is it clear?
Yes.
Very good. Okay, let's move forward. So I should assume that you are clear with the trapezium.
Yes.
Okay. So the next topic is recognizing integrals. Right. So, okay. We have already discussed differentiation, okay, and we have to use that concept over here. Let's say you have f of x, the derivative of f of x is f dash x, right? Now, if you integrate this f dash x, do you know what you will get? You will get f of x,
Yeah.
right? So this is the whole concept of this topic. This is the only thing you need to know, that and here you have to recognize, you need to recognize, okay? You have to recognize what? That you would be given with an integral, and this part basically is considered as f dash x dx. Now you need to see that which function's derivative is this, because that function is basically the answer of this integral. This is the only part, this is the only thing you need to do in this topic, right?
Yes.
Okay, very good. So I will erase all this and we'll consider some examples. Okay, so if you have integral e to the x dx, now this is f dash x. You need to see that which function's derivative is e to the x, right? This is the concept. So if you had f of x as e to the x, the derivative would be e to the x. So you have recognized that yes, the function whose derivative is e to the x is e to the x itself. So the integral would be e to the x plus c. Why? Because integration of f dash x dx is basically f of x plus c. This is how you recognize. Okay, this is a very simple example, but this is how you do it. Is this example clear?
Yes.
Okay, very good. Let's talk about a little complicated example. Okay. The second example is that you need to integrate sine x dx. Now here, Ranjani, you must be knowing that directly, that the integral of sine x is minus cos x. You know
Cosine.
this,
Yeah.
right? But here you are not
Yeah.
supposed to do it this way. The concept in this topic is to recognize. And what are you supposed to recognize? You need to see if this is f dash x, what would be the function whose derivative is sine x? Okay, we need to find that f of x. So we know one
Cosine.
thing. Okay, now listen. We know that derivative of cos x is minus sine x, right? This is what we know. So if we write down cos x here, the derivative should have been minus sine x. But since we do not have a minus sign here, we assume that okay, we had minus cos x because the derivative of minus cos x is sine x. Do you understand this?
Yes.
So this is why the integration of sine x, the integration of f dash x would be minus cos x plus c. We know that the derivative of cos x is minus sine x, but here our question was a bit different. We had sine x only. Okay, so since we had sine x only, we need to modify things that way. So since we had to find sine x, we wanted sine x as a derivative for a function, so we used minus cos x. The derivative of minus cos x is, what is the derivative of minus cos x?
Sine X.
Very good. Do you understand it now?
Yes.
Okay. Let me do another example. No, I will not clear it. I need to. Okay, now you have a bit more complicated example. Third one, 4 under root 2x plus 3 dx. Okay, now here you would already be knowing what the integral of this thing is, right? You simply need to know the power is 1 by 2, you add 1, you divide, and things like that. But that is not the concept here. The concept is to recognize. You need to recognize. Now here we assume, okay, now listen to me. We have this 4. This integral is equivalent to the integral of this. You know this, right?
Yes.
So here this is basically our f dash x under root 2x plus 3. That is, to make things easier for ourselves, we will write it down this way. Now we need to know that what function's derivative is this. Okay, so when we are differentiating, we know that the power is multiplied over here. If we have a function with power 2, 2 comes directly and then we subtract 1, right? And we subtract 1 from power. So if this power is 1 by 2, it means in the original function, this would have been 3 by 2, right?
3 by 2. Yes.
Yes. And another thing is missing. There's a 2 here. So this function should have a 2 here. If we had this f of x directly, and if we differentiate it, okay, this 3 by 2 would become 1 by 2. But the derivative of the inner function is 2. So that is missing here, right? This is it's missing here in the derivative. Do you understand?
Yes.
If this would have
Yes.
been our f of x, we would have, okay, this 3 by 2 part is sorted, but the second point is the derivative of the inner function comes here. So this is not the case. So this means that we have 1 by 2 here, right?
Yes.
And then there's another thing which is missing. And just give me a second. Okay, yeah. And now another thing is missing. If we had this 3 by 2, if we had this 3 by 2 and we were asked to differentiate it, we would have this 3 by 2 over here as well in the derivative, right? We would have had this 3 by 2 over here as well, but this is not the case. So what does that imply?
You have to divide it.
Yes. Okay. So this basically means that the f of x would be 2x would be, okay, this is f of x. This would be 3 by 2. Okay, right. I need to check this again because this is our f dash x, and if I do it directly, I would be okay. Wait a second. Wait a second. Wait a second. No, no, no. We have 4. We already have 4. Sorry. Just give me a second. My pen has stopped working. It's working this way, but wait. Oh, okay, sorry, my tablet is not connected. Just give me a second. Okay, now it is. Right. Okay. So, yeah, so we were guessing f of x, and we said that f of x would have 2x plus 3, and the power would be 3 by 2. Very good. And we don't have a 2 here, so there must have been a 2 over here, right? And then the last point was that if we had this 3 by 2 here, so this would be, there should have been a 3 by 2 here. Since it is not the case, so we'll be having a 3 by 2, a 2 by 3, right?
Yes.
Do you agree, right? So
Yes.
we are left with 4. The integration of this thing is 2x plus 3 whole 3 by 2 divided by 3 plus c. Do you understand?
Yes, I do.
Are you sure?
Yes.
Okay, very good. Okay, let's do another example. Okay, so you need to integrate to sine 4x plus 3 dx. Okay, this is the question. And again, you don't have to integrate it, okay? You don't have to do it the way we usually do it. We have to recognize. And how would you recognize? Now, I can rewrite this question as 2 integration sine 4x plus 3 dx. This is my f dash x, that is sine 4x plus 3. And now I need to work on my f of x. Okay. So, okay, so we know that the derivative of cos 4x plus 3 would have been minus sine 4x plus 3 divided by 4. Agreed? Oh, sorry, multiplied by 4. Multiplied by 4, right?
Yes.
If we had this, then the derivative would have been minus 4 sine 4x plus 3. But since we do not have a minus here, it means we would be having a minus here, because then only then the minus signs would be cancelled out and we would have been left with the plus sign. And the other thing is that we should have a 4, like we should have had a 4 here if this was the case. But we do not have a 4 here. It implies that we must be having 1 by 4 here. And now
Yes.
when we will differentiate this, we will get minus 1 by 4 as it is. The derivative of cos is minus sine 4x plus 3 into 4, and now these things would be cancelled and our f dash is this one. So this means this is our f of x. Now remember, never ever forget this 2. We will write it down as 2. We know that the integration of this would be 2 f of x plus c, right? So 2c is again c, so don't mess up with that. 2 is basically sorry, f of x is basically minus 1 by 4 cos 4x plus 3 plus c, right? Do you understand this?
Yes.
100%?
Yes.
Are you clear with this concept that 2c is basically c again, so we don't write 2c, we just write down c.
Yeah.
Okay, very good. So we are done with our the topics I prepared for today. So any questions?
No.
Sure.
For this you can cancel out the 4, right? And this
Yeah, this 4,
yeah, you can.
2 and 1 definitely I can.
Okay.
So I would be left with minus cos 4x plus 3 divided by 2. Yeah. Okay, this is the answer. Right?
Yes.
Okay, perfect. So anything you would like to ask?
No, it's fine.
Okay, perfect. So I will end this recording. I'll stop sharing my screen.